Okay, I'd like to go over some of the documentation that we're going to need to start developing these applications. Again, my goal is to kind of develop a application from a blank folder. So we're going to need as much reference documentation as we can get our hands on. So I'm starting here with the datasheet, which is obviously the quintessential place to start, but we're not going to spend too much time here as there's not a whole lot of detailed information. Once you download the SDK from TI's website, and I can link that below, this is the folder structure that you are presented with upon extraction. Just to go over these briefly, the BIOS is the TI Rtos. There's some documentation there we'll go over in a second. Here you have the Dsp Libs. We're not going to spend a whole lot of time in here because these are compiled libraries. MathLib is used by the DSP and for some of the radar processing stuff. This is going to be your main directory, and let me make this a little bigger, maybe easier to see. So you have the MMWAVE SDK is going to be kind of our main directory that we're going to be working out of. This has all that documentation, all the demos, all the source code, and such. You have the TI CGT ARM. This is the code generation tools for the ARM processors that we'll be working with. So it has the compiler application, the linker application, and so forth. The code generation tools for the DSP, which we might use a little bit, but we'll kind of pass over for now. And then the XDC tools is going to be a dependency for the CGT tools, I believe. So if we go into the MMWAVE SDK folder, in docs, you have the user guide, which is going to be kind of one step after the datasheet. Kind of talks about getting the demo application loaded onto the EVK and how you go about setting up a blank build environment, which will kind of be the topic of our next video. This is what I would consider to be the main documentation for the MMWAVE radars. Here you have just information on the demos, kind of goes through. You have a flow chart of some of the tasks that are created and the processing that takes place, and here's your task list. Again, those are for the Rtos, which I'm kind of wanting to avoid now to see if we can develop application without the Rtos initially, just to remove that bit of complexity for the time being. This is the actual radar specific API documentation for the Wave API, which is a higher level, and then the link, which gives you actual control over the radar MCU that's on board the processor. Here you have the data path, which is essentially taking the raw ADC information, doing some computation on it, and then pushing it somewhere, whether it be the EDMA or out through one of the peripherals. As we talked about, I think in the previous video, some of the chips don't have a DSP, some of the chips don't have a hardware accelerator, so this is where you're setting up what path your data is going to flow. And then you have the DPUs, which are kind of the frequent calculations done on the incoming radar data. So you have angle of arrival, Doppler ranging, clutter removal, etc. And then here's going to be the documentation for the peripherals. So for instance, if you're wanting to look at the GPIO, you have the essentially external API, internal API, and so forth. And let's go back. This is some of the algorithmic specific documentation. The G track is what's used to track objects in the 2D and 3D environment. And then the CLI, which I kind of thought would be up here, is down here under utilities. So for the command line documentation, look here. So moving on, what we want is the technical reference manual next. And let me see if I can pull it up here real quick. This kind of takes the Doxygen documentation here that we're looking at and goes even deeper. So you have some of the power reset clock management. Obviously, it's going to be present on each chip. Talk about the radar subsystem, the master subsystem, and then basically every other aspect of these chips. So you have the mailbox, which is how you're getting information between the different domains. the MSS, BSS, and DSS. You have your CAN documentation here, and then other SPI peripheral I2C here. So more of a deeper reference source of information here in this document. Okay, moving on. I want to look at the assembly documentation and the compiler documentation. So again, because we're not using an IDE, this is the kind of information that would be done for us. Creating the compiler linker options, creating the memory maps, and I want to be able to do that essentially from a blank makefile. So here is the compiler documentation, and this is just kind of a generic TI ARM compiler. It really has nothing to do with radar applications. It's just a generic compiler doc. So when you're working on any other kind of application that's not even radar specific, this is going to be beneficial if you're using TI chipsets, even ARM in general. And then you have the ARM assembly language documentation. Same thing, it's TI's documentation for their ARM chipsets. And again, same deal. We need compiler options, linker options, memory maps. And so these two documents are going to help us develop both of those. And then finally, I want to point out that there is a DSP reference, and I think that's something that we will get into towards the end. I mean, this is obviously more advanced stuff, but these are TI DSPs that are used in a lot of applications, so this information is definitely great to have. And then finally, I wanted to touch on the Rtos documentation. So if you go back into the main kind of SDK file structure, you have the BIOS, and under docs, you have the BIOS user guide. TI calls her Rtos sysBIOS. Not sure why, but that's what it is. And here you're going to have the documentation on essentially kind of an OS abstraction layer, creating tasks, threading models, and we're definitely going to need this kind of for real world applications. You definitely want an Rtos managing these resources. Once these things get super complex, you're also able to modularize and have different people or groups working on different aspects that can all link back to a well-defined API for kind of running these applications. So definitely something we'll need, but not initially. So that should be a ton of information. Get you going on working on these applications. Again, this is kind of my main jump off point, but then I'll consult the other documentations when I need something a little more specific. And I think we'll go from there. And then the next video is going to be creating that blank application in Makefile and just working our way to a working application that we can deploy to either one of these boards. I have the 1800 EVK and the 68 AOP EVK that we'll be working with. So check back soon for the next video and have a good one.